Now let us learn about Heron's formula. First, let us see the man himself, Heron. Heron was born in about 10 AD, possibly in Alexandria in Egypt. He worked in applied mathematics, and his works in mathematical and physical subject was so numerous and varied that he was considered to be an encyclopedic writer. His books mainly deals with areas of squares, rectangles, triangles, and special quadrilaterals, regular polygons, and surfaces of spheres, cylinders, cones, etc. And now it is only Heron who has derived the special formula, the famous formula for calculating the area of a triangle by using only its side and not height. That is, by using its three sides, and which is we call as Heron's formula. It gives us the area of a triangle. The formula is so useful that it is almost considered to be as an hero formula. Now let us see that formula. It is stated as like this. It is under root s minus a, s minus b, and s minus c. Here s refers to the semi-perimeter. We all know what perimeter is, right? Perimeter is the total length of the boundary. Now semi means half. So semi-perimeter would mean as half of the perimeter. Right? So that is how it is written over here. Now perimeter would be as sum of all sides. Sum of all sides, right? So here our sides are given to be A, B, C. A plus B plus C. This is our perimeter. Now to get the semi-perimeter, all we have to do is divide by 2. This is our semi-perimeter. So what the formula says is that we have to multiply first a semi-perimeter, and then we have to have the semi-perimeter minus one of the length, then minus other length, then minus another length. And we have to multiply all these and take the under root. This would give us the area of the triangle. The proof is not in your syllabus or course, as it requires higher mathematical understanding. So we'll just deal with the formula itself in this chapter or in this class. Now let us see the application, the use of this formula in calculating the area. So first of all, let me just write down the formula. It is under root s. Then we subtract each side from s and multiply. S minus a, then subtract another side and then subtract another side. And this we get our formula. So now let us first find s. S is a plus b plus c divided by 2. Here a is 40 meter. We can take any of these as a, b, c. So I'll take my a to be 40, my b I'll take to be 32 meter, and my c is 24 meter. So let us calculate the semi-perimeter. Semi-perimeter is equals to 40 plus 32 plus 24, which is coming and divided by 2, which is coming up to be 96 divided by 2, which is 48. Now let us substitute this value in our formula. I'll just draw a partition over here. Now when we substitute it, first of all, let us write 48. Then we have to subtract 48. Now we have to subtract 40 from 48. Then 48 minus 32. Then 48 minus 24. And this is what will give us our area. Now let us subtract and write 48 into 8 into 48 minus 32 would be 16. Then 48 minus 24 would be 24. Now it may be very difficult to calculate the multiplication of these numbers. So what we do is we convert each number as a perfect square or a multiplication of a prime number. Just like you used to do prime factorization, here we either prime factorize or we convert them into a square, a perfect square multiplied by any prime number. So let us see how we calculate this. 48 can be written as 16, which is a perfect square, into 3. Then 8 can be written as 4 into 2, which is a perfect square. Then 16 is a perfect square, and then we can write 24 as 4, which is a perfect square, into 6. Now let us take out the terms which are coming twice, and once we pair them up, then we only have to take out one of the term outside. That is, let us pair 16 as there are two 16. Then let us pair out 4. Let me just write in the next line. We have paired out 16, so we'll take out 116 from the square root. Then there are two 4s, so we'll take out one of the 4. And then there is 3 into 2, which is 6, and then 6. So we can have 2 6. And what all is left in the square root is just 1. So under root 1 is 1. So we can easily write 16 into 4 into 6, which will give us 64 into 6, which is 384. And remember to put on the units. Since the length is given into meters, so our area's unit will be 384 meters square. And this is how you will find out the area of a triangle by using Heron's formula. First calculate the semi-perimeter and then subtract each side and multiply by semi-perimeter. And then all that left is calculation. Remember that this method is preferable, that you just pair things up, pair the number up and take out, instead of calculating this whole number and multiplying and then taking out the square root. It is very laborious and it will take a lot of time. Now let us do the second question, example number 1. So here we are given that we have to find the area of a triangle. Two of the sides are given. Let me just write A to be 8, B to be 11, and C is not given. So let me write it to be X, and our perimeter is given to be as 32. We know our so we'll just find out C by using the perimeter. We know our perimeter is A plus B plus C. So just write 32 here is equals to 8 plus 11 plus X. Now we add and subtract it from here. We get 32 minus 11 minus 8, which is equals to X. Our X is coming out to be 13 meter. Now, since we have now got all the three sides, so all that's left to do is to apply Heron's formula. Now, I'll just write it again over here. S minus A, S minus B, S minus C. Now just put in the values. Let me erase this. Which is equal to under root S. Let us take out our S. S is A plus B plus C divided by 2. Here perimeter is directly given, so we can just take out by 32 divided by 2. Since semi-perimeter is a half of the perimeter, so 32 divided by 2, which we'll get as 16. So we'll just write over here 16. 16 minus A, which is 8. Then 16 minus B, which is 11. And then 16 minus C, which is 13. Now let us calculate. Our A is 8. 16 into 8 into 16 minus 11 is 5, into 16 minus 13, which is 3. Now let us take out the perfect squares. So first of all, 16 into, we can write 8 as 4 into 2, then we have 5 into 3. Now 16 can be taken out as 4 because 16 is 4 into 4, then 4 can be taken out as 2. Then we are left with these single terms. So there are no pairs, so we cannot take them out of the square root. So we'll just multiply it inside. 2 into 5 into 3. We have 8 into 2 5s are 10 into 3 is 30. And we'll write the units. Since our length is given to be in centimeters, so we'll write centimeter square. This would be our area of this rectangle, of this triangle. Now let us move on to our example number 2. Here it is given that there is a triangular path. So let us first draw a rough outline. There is a triangular path like this, whose one side is 120 centimeter. So we just write 120 meter, sorry, not centimeter. And then other side is given as 80 meter. Then it is 50 meter. So this is our triangle. A gardener, Dhanya, has put a fence all around it and also plant grass inside. So so we have put fence like this all around the boundaries of the park and also have planted inside. Now how much area does she needs to plant? Now how much area is to be planted? That is, how much is the area of the park? So we can easily find out the area of the park. So let us find it out by using Heron's formula, because height is not given. So we only can take out the area using Heron's formula. Let me do it in the next slide. So my A is equals to 120 meter. Then another side was 80 meter. Then my C is 50 meter. Now let us find out first the semi-perimeter. It is A plus B plus C divided by 2. It is 120 plus 80 plus 50 divided by 2. So let us add this up. It is 250 divided by 2, which is coming out to be 125 meter. Now just apply Heron's formula. So our area is given to be as S minus A, S minus B, and S minus C, which is under root 125 minus 120, 125 minus 80, and 125 minus 50. Now let us subtract and write. It is 125 into 5 into, when we'll subtract 125 from when we'll subtract 80 from 125, we get 45. Then we have 125 minus 50, which will give us 75. Now let me put it over here, and now let's convert them into prime numbers and perfect squares. So 125 can be written as 25 into 5. Here we already have a 5, then which is already a prime number. Then we have 45. 45 can be written as 9, which is a perfect square, into 5, which is a prime number. And 75 can be written as 25, which is a perfect square, into 3, which is a prime number. So let us take out 25, which is 25. Then let us take out 5. Then let us take out 9, which is whose square root is 3. And then all that we have left inside the under root is 5 into 3, which is 15. So let us multiply this. Once we multiply this, we get 375 under root 15 meter square, because length is given in meters. So here we have meter. So this is the amount of area that the gardener, has to plant. Now let us move on to the second part of the question. It is saying that we have to find the cost of fencing it with the barbed wire at a rate of 20 per meter, leaving a space 3 meter wide for the gate on one side. So we have applied the wire all over the place, all over the boundaries, except this part, that is the gate. So when we apply the boundary over here, what we get is 25. So first let us find out the boundary on which the fence is applied. So it is 25 minus 3, because 3 meter space is left, into 20. So this is the amount of price that will cost us. So once we do that, we'll get 247 into 20. which will come out to be 4940, and 20 is rupees, so rupees 4940 will be required to cost to fence the park. Now let us move on to our example number 3. Now here, the sides of a triangular plot are given in a ratio of 3, 5 and 7. Now we know that we can write the ratios as 3x, then 5x, then 7x. So supply x over here. Okay, so and its perimeter is given to be as 3 meter. Now let us consider my A to be 3x, my B to be 5x, 3x, my B to be 5x, and my C to be 7x. To find the perimeter, all we have to do is A plus B plus C, which is 3x plus 5x plus 7x. Now, once we'll add them, we'll get the I to be 50x. Now, let us equate the perimeter that we have found it over here with the actual perimeter that is given, this 3. So our x will come out to be 20. Now, substitute the 20 over here and we'll get the sides of the triangle, right? So we'll get A, which is equal to 3 into 20, which is 60. So I'll just write my A to be 60 meter. Then my B will come out to be 5 into 20, which is 100 meter. 100 meter. And my C will come out to be 7 into 20, which is 140 meter. So C is 140 meter. Now, all we have to do is to find the area using Heron's formula, because we have got the semi-perimeter and we have got the, now let us find the semi-perimeter. It is very simple. It is already given that perimeter is 300 meters. So we'll just divide by 2. So we'll get 150 meter. Now Heron's formula, under root S minus A, S minus B, S minus C. So we'll get S is 150. So we'll get 150 minus A, which is 60. Then 150 minus 100. Then 150 minus 140. Which will come out to be 150 into 150 minus 60, which is 90, 150 minus 100, which is 50, and 150 minus 140, which is 10. Now let us first let us take out the zeros here. So we'll just pair the zeros up and we'll just write 10 in place of each of a pair of 0. So first pair of 0 I've taken out 10, in second pair of 0 I've taken out 10, and then we'll just write 15. 15 we can write using prime factorization as 3 into 5. Then 9 is already a square, and then we can write 5, and then it is just 1. So let us pair things up, 5, 5, and then 3. So what we can take out is 100, 10 into 10, then it is 5, 1 of the 5, then it is 3, and then all that's left is under root 3. So we'll get that area as 15 3s are 5 3s are 15, and we'll get 1500 under root 3. So this would be our area, and the unit would be meters square, because our sides are in meter as our perimeter was in meter. So this is how you will find out the area of the triangle using Heron's formula in different kind of questions that is asked.